It's time to roll at the so-called Mars Yard at NASA's Jet Propulsion Lab. When it comes to operating a rover on Mars, practice makes perfect. It's no small endeavor to execute the most comprehensive science mission ever attempted on another planet. And the engineers tasked with making it happen have left no stone unturned in testing every system they can.
We test everything. We test it at temperature. We test it at environments. We put dirt on it. We do it at tilts. We test it in every configuration so that we can do our best to understand and make sure that we are confident it's going to work. So we've done all that, but yeah, we're still nervous. There's still a lot of things that can go wrong. And debugging problems from Earth is always a little bit more challenging than walking out there and, fixing it.
The Mars 2020 spacecraft is on the final leg of a 7-month voyage to the planet next door. Its mission? Land the Perseverance rover onto the Martian surface inside the Jezero crater. It's dry as a bone now, but scientists picked it because they think 3.5 billion years ago it was a veritable garden spot.
And Jezero really stood out as a potential landing site because within that crater we can see absolute evidence that there was a lake that persisted there long enough that a river flowed into that crater and deposited all of its sediments into a river delta, just like we have here on Earth.
In its day, such a place might have been a rich breeding ground for life, perhaps resembling bacteria or algae here on Earth.
What we are going to be looking for are biosignatures, the leavings of microbial life. Everybody is familiar with the idea that living things are made out of organic matter, and some of that gets preserved. And the idea is that using one of the instruments on the rover, we can actually see how that organic matter is distributed.
The science team did field work in Western Australia in preparation for this mission. The rocks there show telltale signs of life and are about the same age as those in the Jezero crater.
When we look at these ancient terrestrial rocks that have evidence of life in them, what we see is that microbes formed mats. These are layers at the interface between a lake or a shallow sea and the mud at the bottom. That held the sediment together and actually distorted it in very characteristic kind of mushroom-shaped patterns called stromatolites. These are a really obvious kind of biosignature. That will be something that we will be looking for very carefully with the rover.
The evidence the scientists are looking for may not be very obvious. Perseverance will drill core samples out of rocks the team finds particularly interesting. These will be sealed up in tubes and dropped off on the Martian surface for a future rover to collect and send back to Earth. It's a concept called sample return.
So we are so excited about Mars sample return. We are closer now than we've ever been before.
Sample return has been a holy grail at NASA for decades. For engineering and budgeting reasons, it never got a firm toehold before. Now, with 4 successful rover missions under their belt and in partnership with the European Space Agency, the team says it's ready.
But we honestly didn't understand how hard it was, and we would not, in all likelihood, have been successful if we had tried to jump right to that point. This piecewise, stepwise approach where we learned more about the planet, learned more what to look for, learned where to go. I think in retrospect, it kind of had to be done that way.
Even if all goes as planned, the samples likely won't reach Earth until sometime in the early 2030s. Biosignatures are signs of possible life, but not smoking gun proof. Teasing out that question will be a lot easier in a lab here on this planet.
But when we get those samples back in the laboratory, that's what's going to give us our best opportunity to be able to say whether or not some of those molecules that we're finding were actually biologic molecules or whether they could form in other ways. It's a very, very complex question.
And a profound one. If we find a second Genesis in the first place we look, the odds greatly improve that the universe is teeming with life. For the PBS NewsHour, I'm Miles O'Brien.